Hello and welcome to Math with Mrs. Becker. Today in Precalc, we are going to go ahead and start Chapter 4 by looking at Section 4.1. In Chapter 4, we focus on polynomials. Now, a polynomial is an expression that will have variables. Remember, our variables are our letters. Coefficients. Coefficients are numbers that go in front of a variable. And we will be finding the sum of more or one monomials with real coefficients and non-negative integer exponents. Now, I know that that sounds kind of confusing, okay? But the big picture is you have been working with polynomials pretty much all year. They just did not give it that specific name. Like examples of polynomials: 3x squared plus 2x minus 7. That is a polynomial. This is a monomial, this is a monomial, this is a monomial, and they're combined through addition or subtraction, okay? Big thing is all of your exponents are whole numbers, so we will not have any fractions. No variable is underneath the denominator. That means that you don't have any negative exponents, and no variable is underneath the radical. So again, another example, you could have like 3x to the power of 5 plus 2x squared plus 3. That would be a polynomial. Okay, so you are used to seeing these things. Don't let the name of it throw you. Okay, the exponent of the highest power of x that appears with a non-zero coefficient is called the degree of the polynomial. Okay, so what that means is the highest exponent. So here, the highest exponent is a 5. So this polynomial has what's called a fifth degree. Here, the highest exponent was a 2, so this is a second degree polynomial. It's whatever the highest exponent is, okay? And the non-zero coefficient of its highest power is called the leading coefficient. So whatever term has the highest exponent, the number that comes in front of that variable, that's the leading coefficient. That's the number that leads the whole problem. It's the leader. Here as well, here's the highest exponent. The number in front of that variable is a 3. That's called the leading coefficient. It leads the problem when you have it written in those standard form. Remember, you go from the highest exponent to the lowest exponent. So that's why it's called the leading coefficient. Here's a couple more examples. Let's say I have 4x to the power of 7 plus 5x to the power of 3 plus x, okay? So this is standard form. The most amount of the x's to the least. 7x is 3x is 1x, okay? So your degree, the highest exponent is 7. So this is a 7th degree polynomial because the 7 is the highest exponent. Your leading coefficient, x to the power of 7, this is the highest exponent, so the number in front, that is the leading coefficient. When it's in standard form, the 4 is the thing that leads the whole polynomial. Okay. Polynomial functions that have a degree that are less than 5, they actually have specific names. If you have a first degree polynomial, that is a linear function. That would be something like 3x plus 1. If you graph that, it's a line. It's a first degree polynomial because the highest exponent would be a 1. Second degree polynomials are quadratic. So if I have like 5x squared plus 2x minus 3, this would be a parabola. It is a second degree because the highest exponent is a 2. 5 would be called your leading coefficient. Third degree is cubic. So I could have something like 7x cubed minus 2. This would be a third degree polynomial because the highest exponent is a 3. It's actually called a cubic function. In this case, my leading coefficient would be a 7. A fourth degree is quartic. The way that I remember that, think of like 4 quarters in a dollar. If you have a fourth degree, I just kind of think of that association with 4. Fourth degree is quartic. So if I were to have negative 2x to the power of 4 plus 2x squared minus 7, this would be an example of a quartic function. The degree would be 4. The leading coefficient would be negative 2. Now, long division of polynomials, okay, it's something that we did study in Algebra 2, and it's one of the first skills that you always work on when you start studying polynomials, okay? So if you are dividing 3x to the power of 4 minus 8x squared minus 11x plus 1, if you're dividing it by x minus 2, whatever you divide by, that's what goes on the outside. So x minus 2 goes on the outside. On the inside, you want to make sure that it is in standard form and you're not missing any x's. So if I look at the x's, it's 4x's, 2x's, 1x's, no x's. Notice there is no x cubed. So I need to go ahead and put a 0x cubed in that location. This is what goes underneath. I have 3x to the power of 4 plus no x cubed minus 8x squared minus 11x plus 1. Now, when you are doing long division of polynomials, your goal is to make the first term on the outside become the first term on the inside. So right now I have an x. So you ask yourself, okay, if x needs to become 3x to the power of 4, what is it missing? It's missing a 3 and it's missing 3 additional x's. 3x cubed times x is 3x to the power of 4. Now you also have to take whatever values on the top and multiply it by the second term on the outside, which is a negative 2. 3x cubed times negative 2 is negative 6x cubed. Now the goal here is to be able to cancel the first term. So what I need to do is change the signs of all of the terms in the second row. So this would become a negative, this would become a positive. The reason why I did that is because now if I add them, these are opposites, so that cancels. 0x cubed plus 6x cubed is 6x cubed. Now I have 2 terms on the outside, so I need to always have 2 terms here. So I carry down the next term, which is negative 8x squared. Now we start again. X needs to become 6x cubed. So you have to ask yourself, what are you missing? It's missing a 6, so I put a 6 on the top. I need 3 x's. I only have 1, so I need 2 more. 6x squared times x is 6x cubed. 6x squared times negative 2 is negative 12x squared. Now, in order to cancel this term, I need to change the signs of everything in the second row. This becomes negative, this becomes positive. Now I add them together. Positive 6x cubed, negative 6x cubed cancels. Negative 8x squared plus 12x squared is 4x squared. Again, I have 2 terms on the outside, so I need 2 terms here, so I carry down the negative 11x, and we start again. X, the first term on the outside, needs to become the first term on the inside. So in order to do that, I need a 4 and I need 1 more x. 4x times x is 4x squared. 4x times negative 2 is negative 8x. Now, you want to be able to add them together and cancel the first term. So I need to make this a negative and I need to make this a positive. 4x squared minus 4x squared cancels. Negative 11x plus 8x is a negative 3x. Carry down the next term. Start again. I need x to become a negative 3x. So what is it missing? It's missing a negative 3. Negative 3 times x makes negative 3x. Negative 3 times negative 2 is a positive 6. Now when I add them together, I need to cancel the first term. So I need to go ahead and change the signs. This becomes a positive. This becomes a negative. This cancels. Positive 1 and a negative 6 makes negative 5. There is no way to change a letter into a number. So this is your remainder. Because your remainder is negative, you minus it. The value of the remainder is 5. That's the numerator. Whatever you are dividing by, that is the denominator. So this is your answer. 3x cubed plus 6x squared plus 4x minus 3 minus 5 over x minus 2. Okay, and again, this is called long division of polynomials. Hopefully, at least halfway through this, you remembered the process because we have done this in Algebra 2. Let's go ahead and do 2 more just to make sure. Whatever you're dividing by, okay, so here I have 6x squared plus 7x minus 2. I'm dividing it by 2x plus 5. So whatever you're dividing by, that's what goes on the outside. On the inside, 2x's, 1x's, no x's. So I do not have to add any x values. Step 1, I need to make the first term on the outside become the first term on the inside. To turn a 2 into a 6, you need to multiply it by 3. The term on the outside has 1x. I need it to have 2, so I give it another x. 3x times 2x is 6x squared. Now multiply it by the other value outside. 3x times 5 is 15x. In order to add them and cancel the first term, you change all of the signs of the second row. Negative, negative. 6x squared minus 6x squared cancels. 7x minus 15x is negative 8x. Carry down the next term and start again. To turn 2x into negative 8x. Well, to turn a 2 into a negative 8, you need to multiply by negative 4. Negative 4 times 2x is a negative 8x. Negative 4 times 5 is a negative 20. In order to cancel this first term, I have to change the signs of the whole second row. This becomes a plus, this becomes a plus. Negative 8x plus 8x cancels. Negative 2 plus 20 is 18. There is no way to turn a term that has an x into a number that does not contain a variable. So this is your remainder. Your remainder is positive, so you add, it's 18, the value of the remainder is on the top, 2x plus 5, that's the denominator, this is your quotient. One more, now this time you guys are going to step it up. If you look, what we're dividing by has 3 terms, okay? So that's what goes on the outside, x squared plus 2x plus 8. Underneath, 4x's, 3x's, 2x's, 1x's, no x's. Awesome, we don't have to add in anything. X to the power of 4 plus x to the power of 3 plus 7x squared minus 6x plus 8. Step 1, I need the first term on the outside to become the first term on the inside. To turn x squared into x to the power of 4, you need 2 more x's. Now, x squared times x squared is x to the power of 4. X squared times 2x is 2x cubed. Now it also has to go to the third term. X squared times 8 is 8x squared. Now the same thing, I have to cancel the first term. In order to do that, I need to change all of the signs of the second row. This becomes negative, this becomes negative, this becomes negative. This cancels. 1x cubed minus 2x cubed is a negative x cubed. 7x squared minus 8x squared is a negative x squared. I have 2 terms on the bottom, but because I have 3 on the outside, I need to drop down the next term so I always have the same amount here as I do on the outside. Start again. X squared needs to become negative x cubed. So I need a negative and I need 1 more x. Negative times a positive is a negative. 1x and 2x's makes 3x's. Negative x times 2x is a negative 2x squared. Negative x times 8 is negative 8x. Now I need to cancel the first term. So I change all of the signs of the whole second row. The first term cancels. Negative x squared plus 2x squared is just 1x squared. Negative 6x plus 8x is 2x. Carry down the next term, start again. If these 2 values already match, what you put on the top is a positive 1, because 1 times x squared would keep it as x squared. 1 times 2x is a positive 2x. 1 times 8 is 8. Now I need to cancel the first term. So I change all the signs to negatives. Now check this. Positive x squared, negative x squared. Positive 2x, negative 2x. Positive 8, negative 8. Everything cancels. There's nothing left to bring down. So there is no remainder. So your quotient is x squared minus x plus 1. Okay, so that is long division of polynomials, those last three examples. When a divisor is a first degree, so what you're dividing by is something like x minus 2 or x plus 5. There is a convenient shortcut method to divide. It is called synthetic division. It is a shortcut, but synthetic division only can be used when you're dividing by something that's in the form x minus c. So it's a single letter, not a number in the front, no exponents. It is a single variable plus or minus a constant. That's it. But because this is a minus, you have to make sure that you are putting in the box whatever value you're subtracting from x. So it's going to appear the opposite of what it looks like in the question, okay? So this is in the format x plus 3. So that means it's x minus a negative 3. So what are you minusing from x? A negative 3. So you put negative 3 in the box. 5x is 4x is 3x is 2x is 1x is no x's. So here I do not have to add in any zeros. You only take the coefficients, the numbers in the front. So it's a 1, then a 5, then a 6, then a negative 1, then a 4, then a 29. When you are doing synthetic division, you always, 100% of the time, carry down the first term. So the 1, in this case, carried down. The number on the bottom, you multiply it by the number in the box. 1 times negative 3 is negative 3. Now you add these. Positive 5 minus 3 is 2. Multiply. Positive 2 times negative 3 is negative 6. Add. Positive 6, negative 6 is 0. Multiply. 0 times negative 3 is 0. Add. Negative 1 plus 0 is negative 1. Multiply. Negative 1 times negative 3 is 3. Add. 4 plus 3 is 7. Multiply. 7 times negative 3 is negative 21. Add. 29 and a negative 21 is 8. So once you've done all of the process, and you're always multiplying and adding, the last number is always the remainder. Next to the remainder is your constant. That means it's just a number. Next to that would have a single variable, then 2, then an exponent of 3, then an exponent of 4. So my solution here, I have 1x to the power of 4 plus 2x cubes, no x squareds, minus x plus 7. My remainder is positive, so it's plus. The value of the remainder goes over whatever you're dividing by. This would be your answer. So you're doing the same thing. It's just a lot quicker if what you're dividing by is in this format and you can do synthetic division. Okay, a couple more examples just to make sure we've got synthetic division. So again, I am dividing by something that is in that form. So what are you subtracting from m? 8. So 8 goes in the box. 2 m's, 1 m, no m's. So it's 1, negative 7, negative 11. You carry down the first term. In this case, it's a 1. 1 times 8 is 8. Add. Negative 7 plus 8 is 1. Multiply. 1 times 8 is 8. Add. Negative 11 plus 8 is negative 3. Once you've gone through all the numbers, the last value is the remainder. Next to the remainder is a constant, means it's just a number. Next to your constant is an x. So I have x plus 1. My remainder is negative, so I minus. It has a value of 3 over x minus 8, or you could have had it m plus 1 minus 3 over m minus 8. This would have probably been the better answer. If you switched it to x's, you just need to keep the whole thing in terms of x's. Okay, last one, synthetic division. P minus 5. It's in the right format. What are you minusing? You're minusing a 5. 3 p's, 2 p's, 1 p, no p's. So I don't have to add in any zeros. P cubed, the number in front is a 1. Then it's a negative 10, then it's a 20, then it's a 26. Always carry down the first term. In this case, it's a 1. 1 times 5 is 5. Add. Negative 10 plus 5 is negative 5. multiply. Negative 5 times positive 5 is a negative 25. Add. 20 plus a negative 25 is negative 5. Multiply. Negative 5 times positive 5 is negative 25. Add. 26 and a negative 25 is 1. The last number is the remainder. Next to that is your constant. Your variable, this time it's a p. This would be p squared. So I have p squared minus 5p minus 5 plus, because my remainder has a positive value, the value of the remainder is 1 over p minus 5. So again, still dividing polynomials, just a second method called synthetic division. All right, and we are almost done with this section, okay? Remainders and factors. If you end up with a remainder of 0, then the divisor is a factor of the dividend, meaning it divides perfectly. Remember when you talk about factors, when you're first talking about multiplication and division? A factor is a number you can divide by and not have anything remaining, okay? So it divides perfectly. So what you're doing here is you are just dividing, and you can use long division, you can use synthetic division. What you're doing is just seeing if you get a remainder. So determine if this is a factor of this. I cannot do synthetic division. So 2x squared, ooh, I can't go 2x's, no x's. So plus 0x plus 1, is that a factor of 3x's, 2x's, 1x's, no x's? So 6x cubed minus 4x squared plus 3x minus 2. Now all this is yes or no. Does it divide perfectly? Meaning, do you end up with a remainder of 0? To turn 2x squared into 6x cubed, you need a 3 and additional x. 3x times 2x squared is 6x cubed. 3x times 0x is 0x squared. 3x times 1 is 3x. This turns to a negative. There's no such thing as a negative 0. This turns into a negative. So this would cancel. Negative 4x squared plus 0x squared is negative 4x squared. Negative 3x, positive 3x, that means we have 0 x's. Carry down the next term. To turn 2x squared into negative 4x squared, you need a negative 2. Negative 2 times 2x squared is negative 4x squared. Negative 2 times 0x is going to be a 0x. Negative 2 times 1 is a negative 2. In order to cancel the first term, change the signs of everything in the second row. This cancels, this is a 0, this cancels, there's nothing left to bring down, so I have a remainder of 0. So yes, this is a factor of this because it divides perfectly. Okay, here's another one. Again, I cannot use synthetic division. We want to see if this x squared plus 3x minus 1, is this a factor? Does it divide perfectly into x cubed plus 2x squared minus 5x minus 6? To turn x squared into x cubed, you need one more x. X times x squared is x cubed. X times 3x is 3x squared. X times negative 1 is negative x. In order to cancel everything here, this becomes a negative, this becomes a negative, this becomes a positive. See you later. 2x squared minus 3x squared is negative x squared. Negative 5x plus 1x is negative 4x. Carry down the next term, start again. To turn x squared into negative x squared, you need to multiply by negative 1. Negative 1 times x squared is negative x squared. Negative 1 times 3x is negative 3x. Negative 1 times negative 1 is a positive 1. In order to cancel this first term, we have to change all the signs of the second row. Positive, positive, negative. This cancels. Negative 4x plus 3x is negative x. Negative 6 and a negative 1 is negative 7. There is no way to turn a term that has 2 x's into a term that only has 1. So this right here, you guys, this would be a remainder because I can't go from 2 x's to 1x. So no, this is not a factor of this because it does not divide perfect. This right here would be your remainder. Okay, last one. Is this a factor of this? You cannot go 2x's to no x's. So I'd have to go x squared plus 0x plus 9. 5x's, 4x's, holy smokes. So x to the power of 5 plus x to the power of 4. I do not have any x cubes. I do not have any x squareds. Minus 81x minus 81. We want to know if it divides perfect. To turn 2x's into 5x's, you need 3. So x cubed times x squared is x to the power of 5. X cubed times 0x, well, that's 0x to the power of 4. This would be 9x cubed. This becomes a negative. There's no such thing as a negative. This becomes a negative. Cancels. X to the power of 4 plus 0x to the power of 4 is just 1x to the power of 4. 0x cubed minus 9x cubed is negative 9x cubed. Carry down my 0x squared, start again. To turn x squared into x to the power of 4, you need 2 more x's. X squared and x squared makes it x to the power of 4. X squared times a 0x, that's 0x cubed. X squared times 9 is 9x squared. Cancel the first term. Negative, negative, oh sorry, it's a 0, so no such thing as a negative 0, and negative. This cancels, so I'm going to come on over here because I'm running out of room. Negative 9x cubed plus 0, 9x cubed is negative 9x cubed. 0x squared minus 9x squared is negative 9x squared. Carry down the next term, which is my single variable, negative 81x. Start again. To turn 9x squared into negative 9x cubed, what do you need? You need a negative 9 and you need another x. Negative 9x times x squared, negative 9x cubed. Negative 9x times 0x is 0, but there would be 2 x's. Negative 9x times 9 is negative 81x. This becomes a positive. There's no such thing as a negative 0. This becomes a positive, so this cancels. Negative 9x squared plus 0x squared is negative 9x squared. Negative 81x, positive 81x is 0x. Carry down the last term, which is negative 81. Start again one last time. To change x squared into negative 9x squared, well, you need a negative 9. Negative 9 times x squared is negative 9x squared. Negative 9 times 0x is 0x. Negative 9 times positive 9 is negative 81. That changes to a positive. No such thing as a negative 0. That changes to a positive. Cancels, cancels, cancels. Everything divides perfectly. There's nothing to bring down. So yes, this is a factor of this, meaning it divides perfectly. Last little idea for the day. So it says if a polynomial is divided by x minus c, then the remainder, this is so cool, you guys, the remainder tells you what you would get if you took that value, whatever you put in the box. The remainder tells you what the value would be if you replace the variable in that function with that number. Okay, so I'm going to go ahead and do a couple examples, and that will be a wrap for 4.1, but it will make a lot more sense when we do this, okay? Use the remainder theorem, so your answer is the remainder. This is the function if it's divided by x minus 4. So 4 goes in the box. 4x is 3x is 2x is 1x is no x's. So I don't have to add in any zeros. It's a 1, 4, negative 1, negative 16, negative 12. Carry down the first term, it's a 1. 1 times 4 is 4. 4 plus 4 is 8. 8 times 4 is 32. 32 plus a negative 1 is 31. 31 times 4 is 124. 124 plus a negative 16 is 108. 108 times 4 is 432. 432 plus a negative 12 is 420. This is the remainder. So what this means is if I have f of 4, the number in the box, if I change all of these x's to a 4, we should get 420. So I'm going to go ahead this first one and just show you how this works. So the number we divided by was 4. So it's 4 to the power of 4 plus 4 times 4 to the power of 3 minus 4 squared minus 16 times 4 minus 12. We get 420. So that's actually when you're doing when you're doing synthetic division, the remainder tells you if you took the original function and you replace all of the x's with that number, the remainder tells you what the solution would be. So cool. So that's what the remainder theorem is. Let's do one more. So again, if this is x plus 2, you have to realize that that was x minus a negative 2. So negative 2 goes in the box. Here was the function. 4x's. There are not 3x's. You have to make sure you put a 0. 4x's, 3x's, 2x's, 1x's, no x's. So it's 3, 0, negative 8, 11, 1. Carry down the first term. It's a 3. 3 times negative 2 is negative 6. 0 plus negative 6 is negative 6. Negative 6 times negative 2 is positive 12. Negative 8 plus 12 is 4. 4 times negative 2 is negative 8. 11 plus a negative 8 is 3. 3 times negative 2 is negative 6. 1 plus a negative 6 is negative 5. Here is the remainder. What this means is if I have f of negative 2, it should equal negative 5. So if I go ahead and I fill this in 3 times, put a negative 2 in to the power of 4, minus 8, put in a negative 2 squared, plus 11, put in a negative 2 plus 1, you should get a negative 5. You guys, that was section 4.1. Your assignment is to complete the worksheet. Go ahead and make sure that as you're working through the worksheet, you do refer back to the notes. If you need to, you can go back to this video and rewatch some examples. I hope you enjoyed our time together today, and I'll talk to you soon.